Hey, welcome to this presentation, running Go on containers, the issue you didn't know existed. Or maybe you do know it exists. I guess you'll find out shortly. But the main purpose for this presentation is to just raise awareness around this issue. It's an issue that I've seen pop up a few times. So I think the more awareness that we can raise around this issue, the better. But before we dive into this issue, I just wanted to touch base on on a few key things. And the first thing is just understanding what GoMaxProx is. GoMaxProx is an environment variable, but it's also a function that we can use to set the number of operating system threads that can run user level Go code simultaneously. If we express a value less than 1, essentially under the hood, what's going to happen is GoMaxProx is going to use the runtime.num CPU function to figure out what are the number of CPUs that I have on the host and set that to GoMaxProx. So for example, if I'm running Go on my MacBook Pro and my MacBook Pro has 8 cores, the num CPU function is going to pick up on those 8 cores and then use that value 8 to set that to GoMaxProx. Another thing to touch on is what CFS is. So CFS stands for Completely Fair Scheduler. It was introduced in the Linux kernel in version 2.6.23. And essentially what it is, it's a way to make sure that every process that you're running gets its fair share of CPU time, and that no single process is hogging all of the CPU time from all of the other processes. There are ways that you can tweak these values through control groups or C groups for short, but we can touch more on those properties a little bit shortly. Now, so what are the actual performance implications of running Go on containers? I think to really help drive this problem, this issue forward, I've put together just a little example with some screenshots. And the first one is running Go in ECS. So you can see I've got a task definition here where I'm running a single container which has a CPU of 4, but my task has a CPU of 8. You can express the same below in Kubernetes. As you can see here, I'm setting the CPU limit for my container to 4. So some of those C group properties that I mentioned earlier, so one of them here, the CFS period, you can see the ECS agent sets this to 100 milliseconds. In Kubernetes, this is also set to 100 milliseconds, and the CFS quota, which is the amount of CPU time a particular resource can use per period, is set to 400 milliseconds, which is the number of CPUs we have, times 100 milliseconds, which equates to 400 milliseconds. So Kubernetes uses these control group properties to help impose these limits. In Docker, Docker also uses CFS and these control group properties to impose these limits. So how this looks is the CFS period, which we have here, which is 100 milliseconds. Per 100 millisecond period, we know that our container has 4 cores. 4 cores times 100 milliseconds, excuse my writing, equals 400 milliseconds of CPU time. And because GoMaxProx is set to 4, and we're running 4 threads, we can see that each thread is going to run for 100 milliseconds, right? So if we add that up, that's 100 milliseconds times 4, which gives us 400 milliseconds, which means that our Go application is using all of its CPU quota for the full 100 millisecond period. You can test this out locally by setting if you're running Docker, by setting the Linux VM to using 8 CPUs or however many CPUs you want. In your Go application, you can log out the you can log out the value for GoMax procs. And then what you can do is you can use a Docker Compose file and you can set the CPU limit to less than the number of CPUs in the Linux VM. And then what you can do is you can just run that Go application and you can see what GoMax procs is. So we would assume here that GoMax procs would be set to the limit imposed by Docker, so in which case the CFS limit. But no, what's actually logged out is 8. GoMax procs is set to 8, which was this value over here, and not the limit imposed by the container. So why is that the case? Well, Go is not actually CFS aware, and we know that Docker uses CFS to impose these limits. So because Go isn't CFS aware, it's going to not understand these limits. So it's just going to default back to using the number of CPUs of the host, and that's the whole purpose of the runtime.num CPU function, as I mentioned earlier, is to actually grab the values, to grab the number of CPUs of the host and then set that to GoMax procs. So you're probably wondering, well, what's the issue? Isn't more threads better? Isn't running more things concurrently a lot better? Like most things, there's trade-offs, and I think as developers, it's a common issue that we think that, hey, running more things concurrently is actually more beneficial, but it can actually be detrimental to the performance of our application. So to explain why, so just remember we have a period of 100 milliseconds, but now because GoMax procs is set to 8 and we're using 8 threads, but remember that the CFS quota is actually set to 400 milliseconds, right? So what's going to happen is we're going to have 8 threads, which are then going to run for 50 milliseconds, which then equates to 400 milliseconds of CPU time. And then Linux is going to be like, oh, hold on, you've used the full allocated amount of CPU time, right? So to stop you from hogging these resources from the other processes, I'm going to stop you, right? And you're going to have to wait until this 100 millisecond period ends and we start the next period. So in which case, if we have a request that comes in, right, and it gets allocated to this thread, then it's going to run and this request normally takes 50, 60 milliseconds. It's going to run for 50 milliseconds, but then a Go application is going to be throttled. And then it has to wait till the next CFS period to pick this work back up again and process finishing this request, which means that a request that normally takes 50 milliseconds can now potentially take 150 milliseconds, which is a 300% increase in latency. So that's not very good. Luckily, there are easy ways to resolve this. So if you are running Go in Docker and you're running, and you are running these containers inside of Kubernetes, then you have this Uber AutoMax procs package to help solve this issue. I did borrow this graph from their README, and as you can see, anytime we go above this quota, in which case 200%, so the CFS quota would be set to 200 milliseconds, you can see that it greatly affects this P99 latency. Unfortunately though, if you are running inside of ECS, there is this issue here where Automax procs will not work, and the reason being is because the AWS agent sets the CFS quota to -1, and we know that, hey, if we specify a value to GoMax procs anything less than 1, then we know that the runtime.num_cpu function is then going to look at the number of CPUs on the host and set that to GoMax procs, in which case it would be 8. So to help solve this issue, I developed this package here, GoMax ECS. And essentially all it does is it talks to the ECS agent to pull in the task and the CPU limits and then set the correct value for GoMax procs. So you can have a look at this package here. I've also added all the notes and stuff for this presentation in this repo, so head on over and check it out, and hopefully this helps to resolve the issues that you have when running Go in containers and those containers running in ECS. I just wanted to point out that the main inspiration for this presentation was actually 100 Go mistakes. I did borrow a lot of the examples that they have in this book for this presentation, so I just wanted to put that out there. This is actually one of my favorite Go books when it comes to writing idiomatic Go code. But yeah, that's it. Hopefully this presentation helped to raise awareness around a common Go issue, and hopefully now you know some easy ways that you can help resolve this issue. But thanks for listening.